So on the bench today we have this amplifier, rather black amplifier, so it's hard to see, but it's basically a Class D amplifier. It uses a board built by Shaw Electronics, and it's a 6-channel amplifier with supposedly 100 watts output on each channel. And the requirement for it was, when I built it, was for these 3 channels. For one channel was bass, front and rear, because it's used on Rinky Dink sound system, which I'll get into later. Then you've got the mid channel and the treble channel, and that's being driven from a active crossover, which splits the audio into the 3 frequency ranges. So and it's got 3 controls on the front for level on each channel. And so here's a look at the board on the inside the box, and this here is the main amplifier board built by Shaw Electronics. As I said, it's a Class D amplifier, so it should have an efficiency around 80 to 90%. Ignore this bit, that's the latest addition to the unit. But as I said, it should be 100 watts per channel. But having built it a few years ago, I did some measurements, and the highest I could see out of this board, which runs on 36 volts, or it can run from 12 to 36 volts, but to get maximum output, 36 volts is advised. But as I said, the most I could see was 50 watts on each channel. Now, the chip they're using specifies 100 watts into 6 ohms, so that could be the reason I'm not getting maximum output. I was testing on an 8 ohm load, and in the system it's used on, I think the speaker impedances are 4 ohms, so in theory it should give a bit more in that application. But the requirement was that it ran on 14 volts, 13.8 roughly, 14. So I had to build all this stuff here. And this is a switch mode power supply. It takes in the 14 volts or 12 volts or whatever it happens to be, and chops it up with this little circuit here to produce a 38 kilohertz square wave. And it's using a chip that's commonly found in car amplifiers, and then it's using MOSFETs to drive the main transformer, which is a step-up transformer, and then that's rectified and smoothed, and that provides the 36 volts from a 12 to 14 volt DC input. We've got the power input, we've got negative 12 to 14 volts, and the latest addition is for an unregulated input, but I'll get on to that later. And we've got here the outputs. You've got bass on those 2 channels, mid and treble for the front speakers, and the same for the rear speakers. Okay, well, you see this photograph in front of you. This is what this unit was designed for. Now, this is Rinky Dink bicycle powered sound system. Now, you got the idea was built many years ago by Dan Smithers, who's the originator of Rinky Dink sound system. And what you've got here is a 2-person AC generator. You can have 2 people pedaling, and that generates a varying 3-phase AC power supply, roughly maybe 35 volts RMS, It obviously varies depending on how hard people are pedaling, and that's rectified in a power supply box, which is in the middle unit, and then it's regulated down to 13.8, 14 volts, whatever, with a switch mode power supply. And traditionally then that would be used to power the amplifiers. And of course you've got the speakers. You've got one for the bass at the front, and then a mid-range and a tweeter, and the same on the rear, bass, mid, and you can't really see the tweeter. And also this thing's mobile. You can put two people will pedal the front unit and it will move along, or two people will pedal on the back unit as well and move it along. So it can be used in various applications. It can be used static at festivals, or mobile riding around festivals, also for demonstrations. And it's been it first went into use in about 1992, I think. I've been involved in working on the electronics for some years, 25 years I think it is, a hell of a long time. Feels like it anyway. But as I was saying, you've got your 14 volts, which is produced in the switch mode power supply in the bottom of this unit, and under this canopy you've got all the mixers and ancillary equipment, which will run on a 12 volt battery, because you don't want that supply interrupted. You want a constant supply. So all the things like CD players or record players, even, they all run on a 12 volts. But so the main purpose is the AC generator is supplying power via the switch mode to the amps. And in the past we were using basically car amps. Now car amps are fairly cheap and you can get fairly high power ones, and they work fairly well for what they are, but there's one drawback. They use class AB topology. I think that's the right word. Might not be, but I'll use it anyway. So they use class AB topology, which is fairly inefficient, probably 55% at its best. So if you think about it, every watt you're producing by pedaling, 45% of that is wasted in heat that the amplifier's producing as a byproduct of its operation. So it wasn't a very efficient system, but it still worked okay. Of course, in a car application, it wouldn't matter the inefficiency of the amplifier. You've got the bloody big alternator producing about a kilowatt. Doesn't matter whether your amplifiers are efficient or not. But in this application, you've got to produce the audio power by pedaling. So to get it as efficient as possible, we decided a few years ago to go over to a Class D amplifier, and I found the board on eBay, as I said, produced by Shaw Electronics. Now, it's a bit of a stupid way to do it in the way we've got it wired, or half had it wired in the past. We were using a 14 volt supply, which is taken down from the unregulated DC off the generator, and then that 14 volts was going to the amplifier box, but where it was then stepped up to 36 volts. So you're going through two power supplies. You're stepping it down to 14 and up again to 36. So that's even more inefficient, even more inefficiencies in the system. So a few weeks ago, we thought about doing it by taking the unregulated DC straight off the generator, which can go as high as about 55 volts peak, and shoving it into a buck converter. And having looked on eBay, they're fairly cheap buck converters, and that will then drop it down to 36 volts. So that's what I've just done in the latest modification. I'll just show you that. So this little module here is the buck converter. Now supposedly they will handle up to 55 volts without blowing up, which I thought was pretty impressive, and you can get any voltage out of it from 1 volt to 36 volts. That's adjustable on the board, and supposedly it'll handle 10 amps, but I wouldn't trust it at 10 amps, not with that little heatsink. I mean, I've had it running with a 3 amp load, and that gets quite warm. And so that's the latest installation I put in this box. Will now have an unregulated DC coming in, which might go as high as 55 volts, and that'll be then regulated down to 36 volts, which is what the amplifier board needs. And I've stuck it right near the fan because, as I said, it does get fairly warm when it's been on a while. And this whole unit, amplifier, and another one which is also in use, goes in a wooden box, and that's going to get pretty bloody hot in the summer. So what more can I say about it? That's the latest modification I've done to it, and I've done some tests on this board. As I said, I've tested the power output of the Shure Class D board, and I've also tested the THC and total harmonic distortion, and it isn't great, I must say. It's well known, I think, that Class D amplifiers are probably not as clean as a traditional Class AB or Class A. So I think I'll set it up and I'll show you some of my findings about this board. Okay, so I've now got it wired up for testing, and I'm running it on 40 volts. I've got my 2 power supplies in series, 30 and 10, and it's drawing 300 milliamps. That's just quiescent current when it's not doing anything at all. And got it wired up on 2 channels to 8 ohm loads, and I'm monitoring on the oscilloscope. But the problem with Class D amplifiers is you can't connect a scope probe across the output because it's a differential output. So in other words, not like a Class AB where you measure from earth on one pin to the signal on the other pin on the speaker output. Because it's Class D, you would short that output to earth, and you just can't do that on Class D amplifiers. So I'm having to use this little black box here, which is a differential probe I built a few years ago. So it's just measuring the signal between the 2 probe connections rather than earth. And and I'm feeding in at the moment 1 kilohertz from my HP audio analyzer for testing. So I'll just crank up the signal. Until it clips. Okay, and on the analyzer, 1 kilohertz on the right, and we're clipping at 20.18 volts. So just do a quick calculation. So that comes out at 51 watts, which is more or less what I expected it to be. Next thing I'll do is I'll wind it up again. I'll do a THD measurement. I think I said THC earlier. Ha ha. Right, I'll crank it right up again. I've now got the audio analyzer set to measure THD at 1 kilohertz. That's close now to the output. Right, that's just about maximum. And I'm measuring 0.8% THD, which is not terribly good. Not as good as a Class AB amplifier would be. But if you turn the level down a bit, it drops considerably. Now we're down to 0.09% THD. And I'll just reconfigure things and I'll do a test at 10 kilohertz. Okay, I'm now doing an input of 10 kilohertz, and you can probably see there is some slight distortion on what should be a sine wave. You can also see a bit of the switching frequency of the PWM circuit in the Class D output. But let's have a look on the distortion meter anyway. Yeah, we've got 2% distortion now at 10 kilohertz. And if I try and turn it up a bit more, yeah, we're getting just over 3% distortion at 10 kilohertz. I mean, it's not absolutely awful, but it's certainly not as good as you'd get with Class AB. And there is some suggestion when I looked on the forums about this board that the output filtering, inductors and capacitors aren't properly they haven't quite got the right values of inductors and capacitors to get the best THD. But in normal operation, I don't think people would notice that on music, and so it is what it is anyway. So I'll just plug a CD player into it and you can hear it, what it sounds like. Okay, I've now got it wired up to a CD player, and over here some fairly crap speakers, so I'll just crank up the volume. Okay, can't play any more than that because of the copyright crap. It's working fairly well. I think the power supply was dropping out at one point with the volume fairly high. So that's about the end of the video, and if you want to know any more about Rinky Dink sound system, look him up on YouTube. He's got a few videos up there, fairly interesting stuff. So bye for now.